Students, we have this next question. It's given that f to be a function from R to R, and you've got another function g also from R to R, such that we have f of x positive y is equal to f of x positive f of y positive f of x times f of y. And more so, we got f of x to be equal to x times g of x for every x comma y element of R. Now, if limit x tending to 0 of g of x is equal to 1, then we are expected to make the choice which of the following is true. Choice A, f is differentiable for every x element of R. Choice B, if g of 0 is equal to 1, then g is differentiable for every x element of R. Now choice C, f dash of 1 is equal to 1, and choice D, f dash of 0 is equal to 1. Now, as I mentioned to you, either one can be true or more than one can be true. So you need to exhaust all of these options to ensure that you're getting the score. So let me consider the given. So we are f of x is equal to x times g of x. Now what I'm going to do is I'm going to take limit x tending to 0 on both sides. So this in turn would give me limit x tending to 0 of f of x is equal to limit x tending to 0 of x times of g of x. Now this can be rewritten as limit x tending to 0 of x multiplied with limit x tending to 0 of g of x. Now it is given that limit x tending to 0 of g of x is equal to 1. So I am writing that statement. Since limit x tending to 0 of g of x is equal to 1, this in turn is giving me limit x tending to 0 of x. Okay, x is tending to 0, limit of this is going to give me 0. So this in turn would mean limit x tending to 0 for f of x is resulting in the value 0. So this is the first direction you will have to establish. Now, having got this direction, what we will have to do is, from here we will use the definition of differentiable. So we know that f dash of x is equal to limit h tending to 0 of f of x positive h negative f of x divided by h. This is the definition. Now we have this f of x positive y is equal to this, right? So I'm going to utilize this. Since f of x positive y is equal to f of x positive f of y positive f of x times f of y, this would mean f of x positive h is equal to f of x positive f of h positive f of x times f of h. Substitute that. So if you were to take this as 2, therefore 2 would result in f dash of x being equal to limit h tending to 0 of f of x positive f of h positive f of x times f of h negative f of x over h. Now f of x and negative f of x gets cancelled. This in turn would give you limit h tending to 0 of f of h positive f of x times f of h divided by h. You take f of h out. So this is going to be limit h tending to 0 of f of h of 1 positive f of x divided by h. So this is what you've got. Now we will have to find out what happens to this limit. So let me rewrite that. So this is equal to, so I'm going to rewrite this. This is what we've got. This is equal to limit h tending to 0 of f of h over h multiplied with one positive f of x. Now this is with reference to x. This is with the limit is actually tending towards 0 for h. But what we got, since f of x is equal to x times g of x, this in turn would mean f of h is equal to h times g of h. So this is equal to limit h tending to 0 of h times g of h divided by h times one positive f of x. Okay, and what is this? On the left you got f dash of x. But what we got, since limit h tending to 0 of g of h is equal to 1, this in turn would mean our f dash of x is going to be equal to 1 positive f of x. Okay, now this can be rewritten as f dash of x divided by 1 positive f of x is equal to 1. Integrating both sides, we get, so what do you get? Integral f dash of x divided by 1 positive f of x times dx is equal to integral dx, right? But what is this? This is nothing but our ln of 1 positive f of x is equal to x positive arbitrary constancy. You will have to we will have to place that arbitrary constancy. Okay, so now we will have to solve this. And how are we going to do that? So at x is equal to 0, we have already got f of 0 to be equal to 0. So this in turn would mean this is 0, this is 0 plus 1, which is ln 1, which means you got ln of 1, which in turn would mean c is equal to 0. So this in turn would mean we got ln of 1 positive f of x is equal to x, which in turn would mean, because I'm going to utilize this formula, ln a to the base e is equal to b, therefore a is equal to e raised to the power of b. So by that formula, you have 1 positive f of x is equal to e raised to the power of x. From here, f of x is equal to e raised to the power of x negative 1. Now, find out f dash of x. From here, f dash of x is equal to e raised to the power of x. So this means f is differentiable for every x element of R. So that is the first deduction. You see here, f is differentiable for every x element of R. Okay, that is true. But we have to find out if x, g of 0 is equal to 1, we have to find if g is differentiable. Okay, so we will have to move in for that. Now let me check for g of x. Now we know that, what is the connectivity between f of x and g of x? We know that f of x is equal to x times g of x. So from here we know that g of x is equal to f of x over x. Now for x not equal to 0, g of x is equal to, what is my f of x? F of x is e raised to the power of x negative 1. So this is e raised to the power of x, e raised to the power of x. Let me rewrite it like this. G of x is equal to e raised to the power of x negative 1 over x. Now this is for x not equal to 0. Now for x is equal to 0, clearly g of x is given to be equal to 1. Right, so this in turn would mean for every x element of R, g of x is differentiable. Now go back to the question. This is the definition. G of 0 is equal to 1, and we have clearly established g to be differentiable for every x element of R. Now we have to ascertain f dash of 1 is equal to 1 or f dash of 0 is equal to 1, or both of them are true. We have to find that out. So how are we going to find that out? Let me move in here. So what have we got? We have got f of x to be equal to e raised to power x negative 1. Therefore f dash of x is equal to what? E raised to the power of x. Right? So at x is equal to 0, f dash of 0 is equal to e raised to the power of 0 is equal to 1. This means f dash of 0 is equal to 1. Go back here. F dash of 0 is equal to 1. But can we say the same for this? F dash of 1 is equal to 1. If we were to substitute x is equal to 1, f dash of 1 is equal to e raised to the power of 1, which is equal to e. So that means this is not the choice, or I would say this is not the choice. This fails. Okay, f dash of 1 is equal to 1. F dash of 1 is equal to e. So this is a choice we shouldn't even tend towards. So what are the required choices for this particular question? This is the question that has been given. We have worked it out. A is true, B is true, and D is true. So A, B, and D are the required choices. Thank you.